How are you, everybody who is watching this video? I'm very happy to have you today. Okay, my name is Olenjolai&N, single. Simply call me Sir Olenjolai. I'm from Tanzania, eastern of the African continent. I'm very happy to have you. Whether you're international or a national viewer, I'm very happy to have you, and I would like to welcome you into this fantastic moment of receiving good news from the special online channel that is called the Online Diploma Polytechnic Institute of Tanzania, square bracket Olenjolai, and also with the combinations with Tanzania Online Advanced Secondary School in square bracket Olenjolai&N. So I would like to take this opportunity to welcome you into one of our online schools that's called Tanzania Online Advanced Secondary School in square bracket Olenjolai&N. And simultaneously, I would like to welcome you into another one of our online institution, which is called the Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. So this is wonderful enough because the combinations of an institutions with the advanced secondary school, because we are in this session or in this lecture, we are going to cover the same contents that have to be covered in the ordinary diploma, and also the same concepts have to be covered in advanced secondary education. So that's the good news. We have our YouTube channels. Make sure that you read the introductions part of this video so that you get so many informations concerning about how you can access our content. So the next question, after you've been welcomed anywhere else, you get in. So you are inside Tanzania Online Advanced Secondary School in square bracket Olenjolai&N. Simultaneously, you are inside Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. So the next question, what is your visions? Because the book of Proverbs 29 verse 18 say that where there is no vision, people perish. So if we don't have visions, we are going to perish. We who are teaching, and even our students also will be learning through our own platform. So the answer of that question is this one. We have an assignment to teach, to train, to incubate by using different teaching methodology and different teaching aids our students on how they can extract knowledge from the formal and the informal classroom education to combine with the knowledge of the Word of God that written in the Holy Bible in order to solve real life problems. So that is an assignment we have. It's a long-time assignment that we have, but we believe as time goes, we are going to develop and build in the mind of Tanzanian students and even African students and even international students. So we have some of the departments in these online institutions and also online advanced secondary school. One of the departments is called the Departments of Advanced Mathematics, where we are teaching a subject, it's 4 subjects, Advanced Mathematics Form 5 and Advanced Mathematics Form 6. And then we are teaching Basic Applied Mathematics Form 5 and Basic Applied Mathematics Form 6. Again, we have another department in Online Diploma Polytechnic Institute of Tanzania, square bracket Olenjolai, that's called Basic Departments of Basic Engineering and Scientific Mathematics, where we are teaching 6 modules, and one of the module is called which we are discussing and I'm teaching you today, is called the connexity and the differential equation. So the subject of the day in departments of advanced mathematics, we have a subject called Advanced Mathematics Form 5, and just the classes for the Form 5, and then Form 6, excuse me, classes for the Form 6. The topic is called the coordinate geometry 2, right? So this is it's chapter 1. So it's the first chapter in Form 6 education. It's called coordinate geometry 2. But in online diploma or in departments of basic engineering and scientific mathematics, this module is called the conex. The ordinary diploma, what actually the ordinary diploma students used to cover in conex, it's a subset of what advanced students used to cover. However, that in some of the parts where there is a synonyms of the contents, because I know the curriculum of ordinary diploma for the third year students, especially for the part of the connexity. So I know what they have to cover. and also I know the curriculums and the syllabus of advanced mathematics Form 6, especially in the part of the coordinate geometry. So I'll be recording one session or one lecture when they share the same, or they have to cover the same contents. So in case that they have to cover different contents, so from there I will teach the ordinary diploma third year students themselves, and I will teach the advanced secondary students themselves about the coordinate geometry too. But in case of the synonyms, we have to I'll be maximizing the time on recording the single session or single lecture, just like today. So we are in the second subtopic. The first subtopic ordinary diploma and even advanced secondary students, they have to cover about the conic section, which we have covered already. And this second subtopic is called the parabola. Say the parabola. So the parabola is the second conic section. The first one is called the cycle, and the second one is the parabola. The third one is called the ellipse, and the fourth one is called the hyperbola. Okay? So I believe that you've understood. This is lecture 2 in case of the sequence of the lectures for ordinary diploma. But this is session 3 in case for the advanced secondary students. And today I'm going to teach about the standard equation of the parabola. That's the message that has been written in my heart, and I want to take you into the next step right now. These contents for the advanced secondary students have to be covered during by the pre-Form 6 or Form 6 students in the 4 combination PCM, PGM, EGM, and even PMC. And here of the study for ordinary diploma, these contents is covered in the first semester in the third year of ordinary diploma, because we have an assignment to prepare competence-based ordinary diploma student. So I have been giving you so many instructions. Before even I go further, or just take you into today's good news, I would like just to remind you that quickly in both departments, in both online institutions, online schools, online learning institutions, or learning schools, we have online library. So there's a library, we call it online library for Tanzania Online Advanced Secondary School, where we have some tools or some books, some textbooks, some questions and answer books, some materials, some devices, and some materials which help our students to learn and master the subject without any kinds of too much hassle. The first weapon is the syllabus. Really, we recommend all of our students to have a copy, either origin of this book or a copy of this book, which is called the Advanced Mathematics Syllabus for Advanced Secondary Education from 5 through Form 6. So you can order this book or you can order a copy of it. Just go to the descriptions below. You will see you can order in any regions of Tanzania, and then we try our level best to ship it to you. Again, we have Pure Mathematics 1. So this is the one of the textbook. This is the second weapon. So we have Pure Mathematics 1. And then this is by J.K. Backhouse. And also we have Pure Mathematics 2 by the same authors. So we have in our library, you can order. We are just providing service. We are not doing business. We are selling these books with a cheap, very cheap price. But also, in case you are living out of Dar es Salaam, then you have also to pay the shipping costs, so you can ship in any regions within the 31 regions of Tanzania. Again, another weapon is Advanced Mathematics. You have a book, this is the question and answer book called the Advanced Mathematics 1. It comprises problems and solutions of 2003 through 2018. I'll be using this book. You can order it. We have so many books of Advanced Mathematics 1 review in our library store. So you can order it and then we can ship to you. Another first weapons is Advanced Mathematics 2 review. So this also is a very nice book. You can order it. We have in our store. You can order it online and pay the shipping cost, and we advise you as the parent or guardian, you can order the package of this book, because you will minimize your shipping cost. You'll be just paying your shipping cost once, and your students is well equipped with valid materials which have been recommended by the syllabus of the United Republic of Tanzania. If you're an international student, don't be disappointed also. International contents and international text books and questions and answers books and materials are still on process. So Soon we are going to inform you on how you can access them in any country, because we want to cross the borders and help millions of the students in African continents and even other countries. So this now is another material which is very important for all, for both, for the Online Diploma Polytechnic Institute of Tanzania, square bracket OLENJOLAI, and also in Tanzania Online Advanced Secondary School, in square bracket OLENJOLAIM. So this certificate calculator is very important. We are selling, we have different types, but really we recommend Casio function 991 for your students, or for you as the students. You can use it and can last it for a long time, more than 3 years. We have original scientific calculator. We are just selling with a very reasonable price. It is cheap, just minimum price, and compared to the local price and the original scientific calculators, because we have a mechanisms of testing whether it's original or it's not original. So that's all about what we have. We'd like to share with you in advance before we take you from one point to another point now. So let us now, I believe you're serious students, you have your exercise book, you have your reference books, and then you have your scientific calculator, you have your fresh mind, you are ready now to go into the live class. So let us go to the live class. Okay, so let me begin on the quick review of lecture 1 in case of the conics, and also this was session 2 in case of 40, in case of coordinate geometry 2. Basically, what I've taught you there, I've told first of all, I've mentioned how we can cut the cone and get circle, how we can cut also the cones and get parabola, that we're going to start today, how you can cut the cone and then we get the hyperbola, and how we can cut the cone and get ellipse. But near the end of that session, or that lecture 1 or session 2, then I told you about terminologies. Terminologies of what? Terminologies of coordinate geometry 2 that you are going to use in coordinate geometry 2. So I mentioned so many terminologies. Some of the terminologies I mentioned about focus, I mentioned about dielectrics that we are going to use from today. I mentioned about foci, okay, foci, that's a focus. I mentioned about eccentricity, which is eccentricity. I mentioned about latus rectum, okay. Then I introduced to you about the center. I introduced to you about axis. Then I introduced to you about the vertices or vertex, etc., etc., etc. So in case you missed it, we still have most of this. We still have lecture 1 in online in one of our YouTube channels that are providing essential contents for learning in Online Diploma Polytechnic Institute of Tanzania, square bracket OLENJOLAI, which is called the Online Diploma Poly Institute of Tanzania in square bracket OLENJOLAI. So you can just search in the YouTube search engine. Again, so you can access all of these contents in session 2 as titled as session 2, which has been titled as the concept of conic section. The concepts of conic section. So let us go to the today. So today we have a subject, a subtopic that we call the parabola. So just write on top of your paper the word the parabola. Say the parabola. In many cases, I know that this might be your first time to hear this word, the word parabola. However, that we are always watching different stations on the TV by using different antennas, right? We call this different antennas or access of the satellites. And you have the dish antenna at your homes, but you've never bothered. But that's not the case. We use actually, once that in Tanzania or in many of the African countries, once we want to cook for the rice, during the preparations of the rice before actually that we take it and put into the boiling water and cooking oil and other essential materials or requirements, then what happens that we can separate the particles of the rice with other unrequired particles by using a kind of the interesting interesting plate which is in the form of the parabola. Interesting. So the word parabola is not new to you. The structure of the parabolic or parabolic structures that you are talking is not new, because you see the dish antenna. Even if that you don't have a TV or a dish antenna to your home, but you see in the street, in the tall buildings, you find that antennas. You see in the, for example, that in the transmission stations, it is a cellular transmission station, we call it base station. So you see dishes are dish antennas. Okay. So the fundamental question that we have is, what is parabola? So what is parabola? That's the fundamental question that we have. So we say that parabola in the conic section, parabola is a conic section which its distance, or which, okay, in which it's a, okay, in the conic section in which the point, we call it the locus of the point. Should have your exercise book, should have your pen, should have your ruler, and you have to get ready to receive the good news. Receive the good news. So it's the locus of the point. So we say that parabola is a conic section, first of all, so you know that, in which is a conic section. Okay? Parabola is a conic section. Okay. That's not a new sentence for you. Let's go to the interesting point. Parabola is a locus of point. Parabola is a locus of point which moves such that its distance from fixed point, which we call the focus, is always equal to its distance from what? From fixed line, which we call the directrix. So this is the definition of parabola. So parabola, what's a parabola? Is a locus. Say locus. Locus of what? Of point. Which does what? Moves in such a way that its distance from where? From the focus is always equal. Equal to what? To its distance from where? From the directrix. So according to some specific objective that has been laid out by the Tanzania Institute of Education, then we have to teach you how you can derive the equation of the parabola. And that equation of the parabola, we call the standard equation of the parabola. And the next session or next lecture, I'm going to teach you about how you can derive the equation of the translated parabola. It means that the parabola whose vertex is not at the center. Okay? So this is the definition. But the second specific objective, we have to teach you how you can draw the graph of parabola. So to understand this definition, let me just take you into the next part of specific objective of today, that graph of parabola. How can we draw the parabola in XY plane? Well, so first of all, we have to draw our XY plane. In our XY plane, we have 4 quadrants. Okay? So we are not going to focus into all of these 4 quadrants, but we are going to focus so this is the x-axis, and this is y-axis, and this is the x-axis. So this we used to call in mathematics the first quadrant, and this the second quadrant, and this the third quadrant, and this the fourth quadrant. So actually, a parabola should be within either in one quadrant or in two quadrants. So let us start with the standard parabola. So the standard parabola is the parabola whose is the curve, whose vertex is at the origin and lies along the positive x-axis. So remember that this is called the positive x-axis. Here we have negative x-axis. Here you have positive y-axis. And here we have negative y-axis. Okay? So if this is the case, we say that, remember that I told you that in every aspect, say that suppose that this is 10 and this is, let's say, 5. So here we have a focus. So then we say that, okay, it should come up to here. So here we are going to have a fixed line. Do you remember how we call this fixed line? This fixed line in mathematics we call it directives. So you have to listen carefully. Directives. So this is the graph of directives. So then this is the focus. Okay? So here we have focus. This we call the focus. And this is the parabola. We're going to derive this question soon. And this is vertex. So this is the point that we call the vertex parabola. And this is the inner point. Suppose that this is point P, which is x, 1. So the distance from what? From the focus to the point is this. And then this again, here we have another point, which we call the M. Okay? So in this one we call it directives. Say directives. Directives. Okay? Directives line. So this is figure 3.1. Okay, so that's the directives line. So this directives line, and then this the parabola itself can be lines along the positive x-axis, can be lines along the negative x-axis. A parabola can be lying along the positive y-axis. A parabola can be lying along the negative y-axis. Okay, so you have to pay attention when you're learning about the parabola. So that's the figure of the parabola, and this is the structure of the general structure of the parabola that we are going to discuss. So you see the focus, you see the directives, you see the vertex. This is the point, we call the point P. So according to the definition, we used to say that the distance, so suppose that this is S. So according to this definition, we say that it's the locus of the point which moves in such a way that is distance from the focus. So distance, so this is the point on the parabola. So it's distance from the focus, so we call it the PS, is always equal to its distance from what? From the fixed line, which we call the PM. So the distance from P to S is equal to distance from P to M. That's the unique property of a parabola. And that property distinguishes a parabola from cycle. That property distinguishes a parabola from ellipse, and that property distinguishes a parabola from hyperbola. What point? The distance from this point, from the point, any points along the parabola to the fixed point, which is focus, is always the same to the distance from that point to the fixed line, which we call the directives. Remember again, vertex is the center of 40, is the center of the distance between focus and the directives. Okay? In case you have any question, don't hesitate to ask in the comment section here. Comment section is for you and the students to interact with me. Okay, don't assume that you've understood everything. Some of the materials I used to provide once the students has asked the question. So even myself, 90% 80% of what I'm teaching you, I learned them informal. I didn't learn them from school. I learned them myself. Okay. So, and I learned them by asking myself so many questions. So then now, let us go to the next part, which is derivations of the standard equation of the parabola. So we say that let us go to the next part, derivation of the standard equation of parabola. So because the standard parabola can lie in 4 possible regions of xy plane. The first possible regions, it can lie along the positive x-axis. Or this parabola, it can lie along the negative x-axis. Or this parabola, it can lie along the positive y-axis. And this parabola, it can lie along the negative y-axis. Right? So we are going to have 4 different formulas. I'll derive 3. 1 is your homework, because I love you to try during the practice and during the learning period. So once you go in exams, every question will be a repetition for you. So let us begin with part A. We say that if the standard parabola, STD, the standard parabola lies along what? Lies along x positive x-axis. Positive x-axis. Lies along positive x-axis. Okay, so what do you say about this? If the standard parabola lies along the positive x-axis, so you are going to follow some steps. So the first step, we say that consider a parabola in figure 3.2 below. Okay, so let us consider a parabola 3.2 below. So now I'm going to sketch a figure 3.2, which is a detailed parabola. It is a detailed parabola. Okay. So this is y-axis. Then we have the x-axis. Have the x-axis. It is bent. Let me try my level best to draw a straight line across this line. Hopefully. So this is 0, 0. This is y-axis. And here it is x-axis. So you have y-axis and then you have x-axis. Okay, so we say that we have this parabola, which is y-axis, and then you have x-axis. Okay, so here we have a parabola. So this is our parabola, as I said. Then let us have a distance. distance of what? 10, 10, 4. So this is 1, 2, 3, 4, 5, 6. 1, 4, 1, 2, 3, 4, 5, 6. So here we are going to have our directives. So this is our fixed line. Okay, so you have to listen carefully. Fixed line. And this is figure 3.2. Okay. So again, this is the focus. You can find that possibly this line is a little bit, it's not perpendicular to the surface. So this is the focus, we call it S, and this focus usual for this standard parabola, we have a point which is A, 0. This A is a known. And then we have a certain point here, and this is the end point. So it is P, which is X, Y. Then we say that, if you do remember that, in figure 3.1, you have a distance, and this point is called the M. So this point M, it's what? Because remember the distance from here to the vertex, this is the vertex V. The distance from focus to the vertex is equal to the distance from vertex to the directives. So if the distance from here to here it is A, here, so even this one it is A, but in the opposite side. So that's why the equation of directives is equal to negative A. So this point, it is A, it is negative A, comma 1. Negative A, comma 1. So that's a point M. So coordinates of point M. So then here we need to join these 2 points, point P and point S. Okay, so we have 2 points. So point P and point S. So this is negative A. Comma 1. 10, comma 1. So this is 20p, which is x, comma y. X, comma 1. Okay, so you have point S. This is the distance from here to here. And this is the distance from here to here. Okay, so this is our figure. Now, we as mathematicians, we can do great things now. Once we have that, we can do great things. Remember that I told you in the previous session, which is session 3, session 2, and previous lecture, which was lecture 1, that the eccentricity of the ellipse, the eccentricity of the parabola is 1. So the second step, we say, what is parabola? Parabola is a locus of the point moves in such a way that its distance from the fixed point is always equal to its distance from the fixed line. So the second step, we say that we call the formula for what? For eccentricity. So you say the eccentricity is equal to what? Is equal to SP over PM, or vice versa is true. Okay? So we say that, but I told you eccentricity of parabola is 1. Right? So eccentricity is equal to 1 for what? For any parabola. So if that is the case, so we say 1 is equal to, suppose that this is equation 1. So 1 is equal to SP of what? PM. So if we multiply by PM, both sides, then that's why we end up with PM. Okay, distance PM is equal to SP. Okay, so now in terms of the distance, right? We want to find the distance, right? The distance, which we call T sometimes magnitude or whatever. So we say that the distance of PM, this is equal to what? Square root of what? So for the PM, distance from this point to this point. So we say that this is equal to XC. So suppose that this is equation 2. So you have XC minus negative A, which is XC plus A squared, plus what? Y minus Y squared. So the distance PM, this is equal to what? Square root of what? Of X plus A squared plus 0 squared. Okay? So it means simply the distance from P to M, this is equal to square root of what? Of X plus A squared, and this will make the steady equation. Wonderful. I believe you're enjoying the beauty of conics, and especially the beauty of parabola. Okay, so this is still a fundamental concepts of parabola. We didn't get into advanced concepts of parabola. So then we say that we have what we have again distance SP. Okay, distance SP, we want to find the distance from P to S. It is XC minus A. So it is XC minus A squared plus, then we have Y minus 0. So it's Y minus 0, then you square. So then the distance SP, this is equal to square root of what? X minus A squared plus Y squared. This will make equation 4. So you have equation 4, we have equation 3. Let's substitute in equation 2. That will be the third step. Okay? Enjoy the beauty of advanced mathematics. Third step, we say that substitute equation 3 and the equation 4 into equation 2. So to substitute it, we say that we have a square root of X plus A squared. This is equal to square root of what? Of X minus A squared plus Y squared. Then we find we square to both sides. Okay, so once we square to both sides, we get X plus A squared. This is equal to what? X minus A squared plus Y squared. So you go to the first step, right? The first step, this will make equation 5. Right? This will make equation 5. We say that expand terms in equation 5. So expand terms in equation 5. Ladies and gentlemen, welcome to enjoy the beauty of parabola at the concept of the conic section. Right? So then if you expand on the left hand side, we'll have X plus A times what? X plus A. This is equal to what? This is equal to XC minus A times XC minus A plus Y squared. So X times X, this will make X squared. X times A, this will make AX. A times X will make AX. A times A will make A squared. This X times X is equal to X squared. X times A, this will make A X. Then negative A times X, this will make negative AX. And then so we say that negative A times negative A, this will make A squared plus Y squared. So then we collect the terms. So to collect the terms, we have X squared minus X squared because they are same. Then AX plus AX make 2AX. And then so on this side, negative AX minus AX makes negative 2AX. So if you bring on this side, it will be 2AX plus this A squared. Then this is equal to what? Is equal to A squared plus Y squared. Right? Okay. So if that's the case, so this will cancel. So we have 4ax plus what? A square minus a square is equal to y square. So here we have y square is equal to what? 4ax. Because a square minus a square is equal to 0. So y square is equal to 4ax. Therefore, the standard formula was the standard equation, or the equation of the standard parabola, the equation of the formula, the equation of the standard parabola lies on positive x-axis is given as y square is equal to 4ax. You have to remember this equation for the rest of your life. Simply just remember this one. Y square over 4ax, because this is the fundamental concept. Okay. So how many steps we have followed? Just the 4 steps. Simple. No need for you to pray, because if you forget, you have to remember the sketch, the graph. Okay. So we are done with that first case. It's just the issue of doing questions or solving questions by using this. So let me take you into the next part, which is B. We say that derivation. We teach you a derivation of the question of standard parabola lies along negative x-axis. Negative x-axis. Okay, so to derive this, we have always the first step. We say that consider figure 3.3 below. So this figure has x-axis and the y-axis. Let me sketch it here. So this is y-axis and this is x-axis. Okay, y-axis and x-axis. So today we have our standard parabola lies on the negative y-axis. So this is our parabola. It's vertex which is v, which is 0, 0. And we have the focus and the vertex. So focus for this point, we say that we use this measurement. So we have here it is 14. So we say 1, 2, 3, 4, 5. You can say this point. Then here we have 1, 2, 3, 4, 5. So we have this one. So this is focus. Okay, this is focus. And focus is S, because this lies on negative x-axis. This negative a, 0. And here we have our derivatives. Questions of 40 of derivatives. So question of derivatives. So the distance from here to here is a, and the distance from here to here is a, and this is a question of derivatives. On this side now, we say x is equal to positive a. Okay? So here, this is the point, a certain point. Possibly that I didn't draw it well. Okay? But you have to trust me that if you draw by using a protector, you'll find the truth of what I'm telling you. Okay? So then we have a point. Don't measure the quality of these two points by the size, by your visualizations, because this is sketch. Actually have to draw, and you will see that the distance between PM and D is equal to the distance between PS. So this is PM today, which is should be perpendicular. This is M. And this M today it has positive A, 1. So this is point P. So now, so that the first, so this is figure 3 and 3. So this is problem geometry 2 or called comments. Okay. So that the first state, we have a sketch. We go for the second state. Second state, we say that we call eccentricity of parabola is equal to 1, and this will make it SP to be equal to PM. Right? That is. So it means we say that SP, this is equal to the distance of PM, and this is equation 1. Then we have to find the distance SP. So the distance SP, we are using the distance formula of called the geometry 1 that we taught you called the geometry 1. We're looking for SP. SP will be x minus negative A. So this one will be x minus negative A square plus. Then we have again some other point, this y minus 0. Y minus 0 square. So our distance SP, this is equal to square root of x minus 8 is x plus a square plus what y square. So this will make our second equation. Okay? Then we need to know the distance PM. The new distance PM, to get your change, it's the square root of what? PM. So x minus a, y minus 1. So it is x minus a square plus y minus y square. So simply this distance PM is equal to square root of what? Of x minus a square. This will make the third equation. So we go for the third step. The lovers of mathematics, we say that we have to substitute equation 2 and the equation 3 into equation 1. So when you substitute them, we get now our interesting equation. Interesting equation. So if we equate them, because this equation SPM is the square root of what? This is square root of x plus a square, then plus y square. This will be equal to square root of what? We'll be using this same concept even in other conic sections square. So then right now we can square both sides of this equation. Once we square, we get what? X plus a square plus y square. This is equal to what? X minus a square. So this now will make equation 4. So the first step now, which is interesting, we say that expand terms of equation 4 and they simplify. Simplify. So to expand on this side, you're going to have x squared. Just straightforward because we taught you how you can expand step to step. Plus what? Plus y squared. This is equal to what? X squared minus 2ax plus a squared. So you can do some maneuvers and then you find that on this side you can have x squared minus x squared plus 2ax plus 2ax, then plus a squared minus what? Minus a squared, and then plus y squared is equal to 0. So this and this, x squared minus s squared is 0. This will make 4ax, and then a squared minus a squared is 0, plus what? Y squared is equal to 0. So let us make y squared the subject. So y squared is equal to 4ax. And this is the standard equation, or the standard equation for the parabola lies along the x-axis. So therefore we say that the standard equation of parabola along negative x-axis is y squared is equal to negative 4ax. Keep this information. Okay? So again, another piece of information which is very important for you to know is, which I forgot in the first derivation, but thank God because it reminded me in this part B, we say that this one. For this, for the same section, means that from the figure we had there, we have some few points that we have to note. Okay? So these are common, okay? So first of all, we have vertex. We have only one vertex for parabola, which is 0, 0. Second point, we say that the axis for these two is x-axis. If we translate the parabola, then we find that the axis will change. And then we have focus. Focus for this change along the x-axis. Along the x-axis for the negative, we have negative a, 0. Then we have the radius. The radius, or equation of the radius. So equation of the radius, its x is equal to positive a. Okay? So these are the 4 pieces of information that you have to deduce. The x-axis, parabolization along the x. Yes, those are the 4. Okay? Then we say that if parabola lies along positive x-axis, as I told you before, we say the vertex of that parabola is still the same. So the vertex is 0, 0. Then the axis is x-axis. It's not a y-axis. Focus is equal to positive a, 0 at the focus. Then the radius, question of the radius, it is x is equal to negative a. So these are very important because we given some simple examples. We asked to find the vertex of parabola or the focus or the equation of the radius, which actually that you can find those points quickly as possible because you're a serious student. So let me teach you how you can derive the standard equation of parabola when the parabola now lies along the positive y-axis. And I will leave, you have to listen carefully because next day I will leave the homework for you to derive when the parabola lies along the negative y-axis. So this you see, we say that derivation of equation EQN of parabola if it lies along, just in short, positive y-axis. Positive y-axis. So to achieve this derivation, we need a figure. First mistake, always say that consider figure 3.4 below. 3.4 below. Y-axis, then this is x-axis. Let me just sketch in this way. So the vertex here is 0, 0. Let's take 3. 1, 2, 3, 4, 5. And then have 1, 2, 3, 4, 5. So today our derivatives will be along the x-axis. Equation derivatives will be along x-axis. Along x-axis. So this one, y is equal to negative b, because you have to change. Then our parabola will be lying along the y-axis like this. So this is our parabola, and this is just a sketch. That's the y-axis. This is the focus, and then the focus we still call it S, but today this is 0, b positive. 0, b positive. Vertex is 0, 0, and then we say that we have again a certain point which moves along this parabola, which is S. So then we have again another point here. And this is N. Which is perpendicular. This S, no, this is point P, excuse me, point P, which is x, y. And here we have point M, its coordinate are what? 0, negative b. Why 0, negative? Because this is negative b. So 0, and then the x-axis, excuse me. So it is x, negative b, because x is a norm. So the value of x here is x. Well, so that is the figure. This is figure. This is figure 3 and 4. So then, after sketching our conic sections, we enjoy the beauty of, so you see that now stuff have been changing. Now the parabola is relying along the y-axis. Interesting. So for this case, we say that, wow. So you say that we go for the second step. Second step, always you have to remember the definition of eccentricity of parabola, which is 1, and here to be equal to Pm, and this Pm will be equal to Sp. Okay? So this is equation 1. So equation 2, we say that Pm, this is equal to what? Pm. So we have to use the distance formula in coordinate geometry 1. Pm, so x minus h, first of all, square plus what? Y minus negative b, which will be y plus b squared. So simply Pm, after simplifying, then we get square root of what? Of y plus b squared. So this is question 1. Then we have another equation again, we need to know for Sp. So Sp, this will be the distance. We are going to use also distance formula. Sp or Ps is x minus 0. X minus 0 plus what? Then we have what? Y minus b. Y minus b squared. So if you simplify Sp or Ps, there is nothing. This is equal to square root of what? Of x squared, then y minus b squared. This is question 2. Oh, excuse me. This is question 2, this is question 3. So we go for the third step. Third step, we say that let us substitute equation 2 and 3 into equation 1. Okay? So if you substitute it, what do we find? We find that square root of what? Of y plus b squared. This is equal to what? Square root of x squared plus y minus b squared. So then we square to both sides. Okay? So if you square to both sides, we have y plus b squared. This is equal to what? X squared plus y minus b squared. So then we go for the first step, and the first step we have to expand. Expand and then simplify. Expand and simplify. So to expand and simplify, on the left hand side we have y plus b squared. On the right hand side we have x plus y minus b squared. Remember that this B and A distinguishes the axis. Even if that I will be teaching about it or will be learning about ellipse, you will see that the x-axis we call it A, or any coordinates along the x-axis, which is a norm, we call it A, just like your arbitrary constant. And then the y-axis, the arbitrary constant in y-axis is B. Okay. So if you expand this, will make y squared 2by plus y squared is equal to x squared plus y squared minus 2by plus y squared. Well, because now you're a good mathematician, is it a y squared? Okay, so this is b squared, excuse me. This is b squared. Okay? And this is b squared. Excuse me again. Thank you, God. B squared, b squared. So we collect the like terms. right? Correct the like terms. On this side, we have y squared minus y squared plus 2by, then plus b squared minus b squared, and then plus 2by is equal to x squared. So this is 0, and this will make 4by, and then plus 0 is equal to x squared. So simply say that x squared is equal to 4by. That's the equation. This is the equation. So now we have just to write. See how mathematics is beautiful. It's very beautiful. So you say that the standard equation of parabola along y-axis or along positive y-axis is x squared is equal to 4by. So that's the standard equation. The standard equation. Okay, so let me just extract the 4 points that I have extracted before. Okay. So we need to know what vertex, not that vertex. So vertex here is 0, 0. And then we need to know about axis. So the axis of parabola is y-axis. It's not the x-axis. Second, we want to know the focus. So focus is equal to a, 0. Then the first point, we need to know equation of, you can call the equation of derivatives. So the equation of derivatives is y is equal to negative b. So those are the important. You see, the focus, excuse me, you see now, I'm doing mistakes. The focus is what? B, excuse me, okay. The focus is 0, b. That's the focus. Then the vertex, okay, the equations of the derivatives is y is equal to negative b. Wow. So that's how advanced mathematics is beautiful. And that's why that coordinate geometry 2 or conics is beautiful. That's why how the concept of parabola is very interesting. You have to start enjoying it today, even from today. So this is homework 2, homework 3 for ordinary, for advanced in secondaries for the Form 6 or class 14 student. Or this is homework 2 for the ordinary diploma student. Don't worry about the number of the homework. Okay? So we have a question there that we'd like to pose to you. And this will be example 1. This one, derive with 8 of graph. Derive, this is question 1, or example 1a. Derive what? With 8 of graph. Derive the standard formula or the standard equation of parabola lies along negative y axis. And B, once you derive, then we say that state its vertex, focus, axis, and the what? Dialectics and the question and its question questions of dialectics. So do that interesting work, and then you'll enjoy, and you'll find yourself that now you are absolutely mathematicians for the rest of your life. Okay, this is the end of lecture 2 for the ordinary diploma students who are in third year, who are learning conics or coordinate geometry. And it's the end of session 3 for advanced secondary students who are in class 14 or Form 6 or pre-Form 6. I would like to invite you in the next lecture, which will be lecture 3 now, which will be solving some examples or some problems. But before solving some examples, I will teach about the length of lattice spectrum, how we can determine length of lattice spectrum for the parabola lies along the x-axis and for the parabola lies along the y-axis. Next, I will teach you some examples, and then we'll see possible that in the next sessions, I will teach you about the translated or the standard, how we can derive the standard equations of the translated parabola. Later on, we'll go how we can derive the equations of how we can show that a tangent line, it's just a straight line, it's a tangent to the parabola, or a straight line, it's a normal to the parabola. So we are going to cover all of those concepts. Stay tuned, stay focused. Before I end this session, first of all, I appreciate and I thank God who have created me in his own image and likeness, and I thank God who have built the gift of teaching, because I am teaching and teaching is me, and I thank because he has been faithful. And even I thank God who have been with me in preparations of this session or this lecture for the ordinary diploma, for the best technicians, and also for the best mathematicians in the country and even worldwide. Again, I thank God who have given you opportunity to be with me. May God bless you abundantly, and may God teach you more than what I taught you. And I invite you in the next sessions. And before I invite you in the next session, I ask you that to press, it means that to make sure that you click the subscribe buttons in our YouTube channel of either the one for online diploma, just for ordinary diploma, or the ones for the advanced secondary education or secondary school, because we are going to have more than 500 videos in each of these YouTube channel. So make sure that you subscribe, and then you'll get official notification from the YouTube community once we upload any new video about advanced mathematics or about basic engineering and scientific mathematics. Again, remember to share these contents with your classmates or with your schoolmates, or with your friends, with your young brothers, with your elders, with your children, if you're a guardian to your parents that are watching right now. And then make sure also read the descriptions. But again, in case you feel from your heart that you want to give God or to offer God your free willing thanksgiving offering for what he has brought in your house, in your field, in your place, in your school, in your just in your uncle's place, or anywhere else, he has brought these fantastic contents to help you to understand coordinate geometry too. So you can offer your free willing thanksgivings in order to support the running cost through this telephone number 0759745331, and then your free willing thanksgiving will be received in order to pay for the running cost, because as I told you that we have a vision to make more than 500 videos and upload them in our YouTube channel. So it means that it's very expensive just to produce one video of the lecture. It's very expensive until that we upload the tools, some of the intermediates were there, until it reaches to your place is very expensive. But remember, the sponsor of this program is God Himself. And because our God is greater than the running costs for this program, so we are not fearful, and we are not even astonished, and we are not even disappointed, and we trust in the Lord, and we believe in the Lord that everything gonna be all right. And that's why that I'm inviting you, because even yourself, you are a child of God, and even you are a servant of the living God. So may God bless you. I'm always praying for my online students, and also I ask you also to pray for me, for God to give me good health and to bless me abundantly, and to bless even my next generations to take this work into the extraordinary level and even into the high definitions quality. So may God bless you. I love you so much. Whether you're national or international students, welcome to enjoy the beauty of mathematics. Welcome to enjoy the beauty of mathematics. And then remember that. Think how you can take this information and convey them or use them effectively to solve a particular problem in your community. May God bless you until we meet next session.